Hello, my name is Emir and welcome to my video. In this video, I'm going to briefly explain how I built the Seesaw simulation project and the key decisions behind it. Let's begin. On the screen, there is an information panel at the top, and this panel shows the total weight and the torque on the left and the right sides of the plank, and the next incoming weight value and the current tilt angle. In the center, you can see the seesaw plank and a pivot. Users can click anywhere on the plank to place a weight, and the seesaw rotates based on the torque differences between the sides, with the angle limited to plus or minus 30 degrees, as you can see in here. And finally, at the bottom, there is a reset button to restart the simulation. Now let's move on to some logic structures behind it. The JavaScript side code mainly the handles users interaction, some calculations, some UI updates, and some state managements. I kept the logic simple and readable for some reviewers or contributors. Now I just want you to show some calculations. Each weight has a value and distance from the center, and each side's torque is calculated by multiplying these factors or values, weight value and weight distance from the center. And to calculate seesaw angle is derived from these torque differences, but I just scale it down bit by dividing with 10. According to task example, I just wanted to use the same factor, but it, this doesn't follow the real world physics rules, but it creates a clearer and more meaningful visual behavior on the screen. And I kept the max and the minimum angle in between the 30-degree, as I said. Now I added some state persistent using local storage in here. Weights and the next weight value are stored, and on refresh the state is restored and created some new elements about weight element, and the right values like the total torque or the seesaw angle recalculated instead of being directly stored in the states. And the main challenge was for me the handling click positions once the seesaw started rotating. Reading click positions directly from the rotated plank caused some problems for me. I mean, the incorrect placement near the edges, especially. If I clicked here, the weights were placing in here. So, to solve this problem, I introduced a separate plank click area and handled these clicks, the plank's local coordinate system using with the offset x value. This keeps weight placement stable and predictable even when the seesaw is tilted. I am aware that more complex mathematical alternatives, but for this task, I just wanted to use the simpler version. The local coordinate approach was more practical for me to use offset x value. I guess that's all for me. Overall, I focused on clarity and stable interaction rather than the real physical accuracy, real physical rules I know. Some trades-off or alternatives are documented in my README file. I guess that's all. Thank you for watching my video.